All right, so in this lesson, we talk about angle bisectors, and more importantly, what angle bisectors create when we have triangles. So we're going to bisect the angles of triangles. What is created? So first, by the end of this lesson, you should be able to do two things. Number one, understand the properties of an angle bisector. We've talked about those before. Yes, you know what they are, but it's always good to review. So that's what we're going to start with. And then number two, and probably a little bit more important today for this focus, is I want you to be able to identify the properties that angle bisectors of a triangle create. So if I ask them for you, or have you produce them, you should be able to confidently discuss them. But first, a brief review of angle bisectors. What is it? Good question. I'll answer it. It is a line, and you know we could add to that, and we could say it could also be a ray, it could be a segment. Lots of things it could be. That divides an angle into two congruent adjacent angles. Again, adjacent means next to, congruent means, good, correct, equals. So let's use this example real briefly. So if I want to label this, we're going to label this angle down here, angle A, B, C, and we'll make this point right here, D. So we know from this diagram, we're going to state that segment BD is the angle bisector. Cool. So since BD is the angle bisector, we'll say up here, so we have something that divides an angle into two congruent adjacent angles. So we have that line, so now we have two congruent adjacent angles. So since BD is the bisector, we could say that angle ABD is congruent to angle, let's keep the order the same, CBD. So we have two congruent adjacent angles. Any questions? If you can't ask a question, you're not here. I saw one of you raise your hand though. I saw that. Student number 5. All right. So now how does this relate to triangles? Because that's what we're going to focus on. You did a review activity earlier in the week, and we have said that, or you've discovered the fact that if we bisect every angle in a triangle, those three bisectors intersect at one point. And it's this point, as you can see in this fake diagram I made right here. It's that one. And we have angle bisectors because we have congruency there. Over here we've got congruency and congruency. And lastly, we'll do a little star here. Congruency. That's a star, I think, or whatever. It's whatever you want to make that. Congruency and congruency. So those are angle bisectors. They have created a point, and that intersection has a name. We researched and found that name. I know, I can hear you guys shouting out right now. Okay, I'll take it. I got it, yes. It is the Incenter. Well said. Congratulations, all of you. It is the Incenter. But just like the Circumcenter before us, the Incenter has a very special property with triangles. You can't go anywhere because you're at home, so you're going to ignore the bell. So again, we're going to use Geometry Sketchpad to do a quick diagram for us. Following our brief interruption, I apologize for the wait, but I know you guys love my lecture, so you're okay if it takes a couple more minutes. We are going to explore this concept. So I have already done some work. So I have, boom, I bisected the angles already. And again, so we have seen that we have this intersection right here. So let's create this intersection point. And you know, for funsies, what are we gonna call it? I say we call it the Incenter. Exclamation mark, because we love incenters. And now for the sake of this presentation, we're gonna go ahead and re-hide those angle bisectors. So again, they intersected and they form this Incenter. So today we're gonna focus on this angle B. So again, here's our angle right here, angle B. So look, if we alter our triangle, notice how the incenter is always moving. But this time, no matter what kind of a triangle we have, it's always staying in the middle. Why is it staying in the middle? Well, the property with the incenter that's special and why we learned it is because the incenter is staying an equal distance away from something, just like the circumcenter was. What is it? Well, again, why don't we use the concept of a triangle to create? So if we make a triangle at our incenter is our center of our circle, and we're going to draw out our circle, and oh, look at that. Our triangle has, our circle has intersected our triangle, oh look at that, in 3 places on each side of our triangle. So I wonder what that means. Well, let's take a look. So if I construct a line or a segment from the center to about where we intersected, I would say right there. What do we call that line right there? Good, correct. It's the radius. And if I construct this radius right here, and if I construct this radius, let's say it's right there, you know, not quite close. We're going to get more into this particular concept, but if I measure this segment, look at that, that's kind of big, sorry about that. And I am going to measure this segment. And I am going to measure this segment. Oh, and I got a little bit off of that one. But again, I'm just freehanding it right now. They are pretty close. And when we get into it, you're going to see that the distance from the incenter to each side of our triangle is going to be congruent. So the last thing for today, if we go back to our incenter, the reason we're finding the incenter is because the incenter is an equal distance from all 3 sides of the triangle. It's going to be actually at a specific part that we're going to get more into it with our activity coming tomorrow. So now remember, you have an assignment. On Skyward, you have a short quiz. You have to give me a 3-sentence summary of what you learned today in this video. Additionally, you're going to have asked a question just to give me a question as to something you are not quite understanding or something you need a little bit more clarification on, in whatever way you want to word that. Good luck.